Hi, Isabel and Grace. I'm ready to do lesson 65 with you. Are you ready? Let's do it. This lesson has two completely different topics. The first one is adding radical expressions. Let me scooch that over so you can see it. And then the second one is weighted averages, a super popular SAT question. Okay, so two completely different topics. Let's tackle adding radical expressions. I'm on page 264, starts at the bottom. I'm going to do example 65.1, and it looks like this. We're told to add 4 times the square root of 2 minus 5 times the square root of 2 plus 12 times the square root of 2. Okay, you guys, this is where it gets really easy. When you're adding radical expressions, the radicals behave just like variables. So pretend this is an x and an x and an x. They all match, right? So in this case, if it was 4x minus 5x plus 12x, we would ignore the variable and we would just add the coefficients, right? Well, that's exactly what we do. We're not doing that problem, but it looks just like it. It's exactly what we do. These are all 2's, by the way. Kind of hard to tell. So, if the radicals match, we simply add or subtract the coefficients on the outside, just as we would if they were x's. So we have 4 minus 5 is negative 1, plus 12 means that the answer is 11 times the square root of 2. Easy, right? Let's try another one. Example 65.2 looks like this. Again, it says add. I'm not writing that. 4 times the square root of 3 plus 3 times the square root of 5 minus 6 times the square root of 3. Okay, do you feel your brakes going on? We have 2 that match and 1 that doesn't. So again, it's just like if we were using letters. If we have some that match, we can combine them. If we have one that doesn't match, we can't. So 4 minus 6, we're comparing the 2 square root of 3's, and we can combine them. So that gives us a minus 2 times the square root of 3. And then this dude that doesn't match, he's just by himself. So that's our final answer. All right? Fairly simple, fairly straightforward. Just pretend that the radical values are variables. It works exactly the same way. So I want you guys to try example 65.3, which you should have no problem with, and 65.4 is kind of a trick question that is super easy. So check it out. Work those two examples. Go ahead and pause the video. Work those two examples together. Check your solutions in the book and see what you can do. All right, now that you're back, let me cross off adding rational expressions, and we're going to talk about section B now, which is weighted averages. Weighted averages are best explained, you guys run into them all the time, when you have a class where you might have like 4 or 5 different tests over the course of the semester or the year, but they're worth different amounts. They're not all worth the same amount in calculating your total score. So let's look at example 65.5. Oh no, 60, yeah, it's 65. I made the wrong number there. 65.5. And I'll read you the story. It's in the book on page 265. So read along with me. Jim's scores were 60, 70, 80, and 90. What is the weighted average of his scores if the tests were weighted 1, 2, 4, and 6 in that order? Well, the first thing I would say is that his teacher's making it unnecessarily complex, but that's all right. We can handle it. So here's the little formula that we use. We're going to take each one of his scores and multiply it by the weight of the score. So I'm just going to write this, the weight of the first test times the score of the first test. Then we'll add the weight of the second test times the score of the second test. Then we'll add the weight of the third test times the score of the third test, and so on, for however many tests that you have. So that's the calculation that we'll do on the top. And then we're going to divide it simply by the total of the weights. And again, I'll put the dot, dot, dot to indicate you keep going for however many different test scores you have. This is our formula. This is what we'll use. So let's go back to our situation with Jim and use that formula to see how it works. His first score was 60, and the weight of the first test was 1. So for the first number, we'll put 1 times 60. I'm pulling this information right out of the problem. For the second test, the weight of the test was 2, and his score was 70. For the third test, remember he's got 4 tests in all, the weight of the score is 4, and we multiply it by 80. And for the fourth one, the weight of the score was 6, and he got a 90 on that one. Now, I've used dots to indicate the multiplication. I'm going to switch them over to parentheses so that you can see it the way we're used to seeing it, okay? And then we divide this, delicious, I guess you couldn't see the end of that, sorry, by the weights. And again, we have 4. Our formula only shows 3, but that's all right, we can handle it. It's 1 plus 2 plus 4 plus 6. And there are all my weights. I've already got them right there in the problem. All right? So now it's just a simple matter of doing the math. So let's grind that through. We will multiply 1 times 60 is 60, plus 2 times 70 is 140, plus 4 times 80 is 320, plus 540. I'm just doing the multiplications, and notice that even though they're big numbers, I can just multiply the tens place times the 1 and add the 0. All right? And then in our denominator, 1 and 2 is 3. 3, and that much is 10, so it's 13 on the bottom. All right? So we're just simplifying at this point. Straightforward. The hard part here is in setting it up. All right, and now we'll add it again. I see that this much is 200. I'm just showing you how I do this mental arithmetic, which I guess makes me mental. 200 here, and this is what, 860. So when I add the 860 and the 200, I see that I have 1060 on the top, 13 on the bottom, and I'm not going to take the time to show the long division, but if you worked that out, and I would love for you to work that out by hand, you'll see that this comes to 81.54, not 54. Okay? So what that tells us is that given these scores on his test, his grade for the class would be an 81, which, as you can see, it's really good because he had a couple much lower scores, 1 lower score, but because the weights of these tests were less, his grade for the class reflects his much higher scores, his scores that were weighted higher. So that's how you do a weighted average problem. They are very straightforward. They are very common, you guys. These show up on a lot of placement tests like the AccuPlacer. They show up on SAT tests. That's the formula that you need to use. And if you go ahead and look at example 65.6 in the book, it's exactly the same. Let me just show you briefly so that you will not be stymied when you get it. Let me flip my page. Example 65.6. Ooh, stack my paper. Example 65.6. What's happening in this one is that in the graduate level course Smith was taking, each of the 3 tests were weighted 20%, and the final paper was weighted 40%. So we had test 1, test 2, test 3, and the paper. Okay? And they were rated 20% for each test, and the paper was weighted 40, okay? Now this is much more like you're going to see actual classes in your real life. Teachers usually tell you what percent of the grade they will be. They don't usually weight them like we did in our other problem where they give them a certain number of points. So this is real life. This is the way you'll see it in the real world. And when we're weighting these problems, when we're trying to set up this formula, when we do the weights, we'll simply convert the decimals to percents. So I will do that just to show you. We would convert 20% to 0.2. You could put the zeros if you wanted. That doesn't change or help anything, and you can keep it simple. So now when you go through to weight his scores, he's also, these are their weights, and then I'm going to scooch this over. The scores are also given as percentages. His scores on the first 3 tests were 60%, so we're going to make that a 0.6. His score for the second test was 0.7, 0.8, and his final paper. Can you see that there? So again, they're all being given as percents in this problem, and we simply convert them to decimals and then do the multiplication. So I'm going to let you guys tackle the rest of 65.6 on your own and finish working this problem through. And again, you'll find that information very helpful as you go to set it up. All right, that's lesson 65, you guys. Short and sweet. Good luck with the homework. I will see you for lesson 66.